numbers which are only divisible by themselves and 1 are known as prime numbers. Prime numbers are vital to number theory. These numbers are the building blocks for integers and lay the foundation for hundreds of theorems. They are also applicable to the real world. They lay the base for cryptography, like RSA, and are used for algorithms in data structures. One important thing to note is that there are infinitely many primes. This was proven in 300 BCE by famous mathematician Euclid. The proof is a standard proof by contradiction, where it is initially assumed that there are a finite number of primes. Despite their wide usage in both pure and applied maths, much about prime numbers is still unknown. One mystery revolving them is the pattern behind prime numbers. As of right now, there is no efficient exact formula that predicts the next prime in a sequence. Now consider this. There are some pairs of primes that have a difference of 2. For example, 3 and 5, 11 and 13, 107 and 109, and so on are all examples of this case. These pairs of primes are considered as twin primes. As you check more and more numbers, the abundance of twin primes decreases. If there are an infinite number of primes, then there should be an infinite number of twin primes. However, this is not the case. It is actually unproven whether or not there are an infinite number of twin primes. This problem is known as the twin prime conjecture, and it was first proposed in 1846 by French mathematician Alphonse. There have been some significant breakthroughs in this conjecture over the years. In 2013, Yi-Tang Zhang proved that there are infinitely many pairs of primes that differ by no more than 70 million. In the following year, a collective effort known as the Polymath Project reduced this number down to 246. It still remains unproven to this day, however, but it is a classic example of how problems in math can be so easy to understand, yet so complex to prove.